Sorry, wrong one. This is not your assignment 4. This is assignment for my other class. Okay, so let me find the correct one. Assignment number 4. Which is this one, which is eigenvalue, eigenvector problem. Eigenvalue, eigenvector problem. Okay, so it's due in 1 week time, which is the 21st. Okay, the 21st, and our test is on the 27th. So we have time to talk about the solution for this assignment. And of course, I'll be giving you one bonus assignment. One bonus assignment. It's up to you. You want to do it or not? Which is the review of past year test 1. So that you are familiar with the format and the kind of question, the level of difficulty of the questions. Okay, so this paper you can download it from the e-learning portal. Okay, let me share you the e-learning portal. Okay, which is this one. Okay. Okay, this one, assignment. Okay, let me change this to your view. Yeah, this one. So I have no lecture slides for this. So there's no slide prepared for this topic. So please write your own notes based on the lecture video and of course based on the book, chapter 27, session 2. And then this is the lecture video. The lecture video is based on the textbook, an example from the textbook. And then this is the your post lecture reinforcement of understanding exercise. So eigenvalue and eigenvector problem. So this is due 1 week from today, 11 a.m. Okay, and then we have our test on the 27th. Okay, so what I'm going to do today, is to not to talk about assignment number 4, but to talk about assignment number 3. Assignment number 3. Okay, so this is assignment number 3. So I think you have done this. So note that if you gone through the exercise, the assignments, you notice that there are 3 steps. There are 3 steps which correspond to our CLO of the class. CLO1, CLO2, and CLO4. CLO1 is basically try to find the governing equation. So that is the step 1. Step 1, try to find the governing equation using all the physical laws that you have learned. So for example, assignment number 2 was the bed length, right? So basically finding, there's no law basically. Sorry, assignment number 1, which is your parachutis, So you do the free body diagram, use your Newton's second law, and then using the second law, you get the governing equation, and you solve it using 2 methods. One is the numerical methods. The other one is using the analytical method. So you compare your analytical result and your numerical result and see what are the errors. What are the errors? So assignment number 2. What was assignment number 2? Assignment number 2 is root of equation, basically the bed length. Assignment number 3 is system of linear algebraic equation, which is this one. And the first question is always, show you that prove the mass balance equation. So this is conservation of mass. Conservation of mass. So conservation of mass, from the conservation of mass, then you can find what is the governing equation. So this is just one governing equation for reactor number 1, which is this one here. Okay, so it seems so quiet now. Do you have any difficulty or any problem with my voice? Is my voice clear enough for you? Loud and clear?
Okay, Doctor.
All right, thank you. Don't keep too quiet. Saya takut saya bercakap seorang-seorang aja. All right, so this is the one. So the first one is, of course, developing or finding the governing equation. So this is one of the equations. And then in this case, we solve the governing equation using Gaussian elimination. Gauss elimination and Gauss-Jordan. Okay, and then, of course, the last one, we will check for the error analysis, if they have error analysis. In this case, we do not have any error analysis, but what we're trying to do here is to see your understanding. Which one method is easier, either direct method or iterative methods. Okay, so if you watch my video, I think I mentioned there are two kind of methods. One is elimination methods, which is your Gauss elimination, your Gauss-Jordan elimination, right? So that's the elimination method, or sometimes we call it direct method. And the other one is iterative method. Iterative method means you have to repeat, you have to iterate, you have to redo the calculation over and over, okay, with different values of x1, x2, and x3. In this case, C1, C2, and C3. Then iterative method, we have Gauss, Seidel, what's the other one? Jacobi and Jacobi. So there are four methods here. There are four methods. A lot more, I guess, in the textbook. So Gauss, Jordan, Gauss, Seidel, and Jacobi. So these are the methods that covered in the lecture. So now, if you watch the video, then the assignment is again, like I mentioned before, is for you to test your understanding. Test and reinforce your understanding. So this question is from past year paper. I don't remember which year. I think this was a long time ago. But I think this is still relevant. Still relevant because this is trying to test you on the topic of system of linear equations, and then try to solve this either using in this case it's just using elimination method, because part E, iterative method, it is just saying you to set up the equation. It is not asking you to solve the equation. Okay, just to set up the equation. But anyway, if you continue part E, not only just setting up, but also solving it, you can see that the result should be the same. Should be the same as whatever method you are using. Okay, so now let's start with the solution, not the solution. Let's discuss about this assignment number 3. Let's discuss about assignment number 3. So the first question here, it says, prove the mass balance for equation reactor 1 is this. Okay, so what is the law that we are using here? Anyone? What's the law that we are using here? I think it's written there. It is written there, which is it says here the mass balance, mass transfer into, so that the mass transfer into each reactor will balance the mass transfer out. So this is basically conservation of mass. Conservation of mass. It is already given there. I'm sorry, I think I have some issue here with my laptop. Okay, let's, I want to change color here. I want to change, never mind, just use, I think black is okay. So let's do this question here. So what I'm going to do here is this one. So question number 1, question number 1. Okay, question number 1. Oh, before that, let me have my reference. Okay, so it says that prove that the mass balance for reactor 1 is 500 plus C2 plus 3C3 equal to 17 C1. Okay, so And we are interested at this point here, this reactor. So it is very straightforward, right? So in this case, it says that the mass transfer into will balance the mass transfer out. So basically, summation of mass in must equal summation of mass going out. Or I just put it like this, mass in minus summation of mass out equal to 0. Okay, this is one way of doing the way to see it. So this is just mass balance, mass balance. So let me start with reactor number 1. So reactor number 1, we can see that for reactor number 1, is reactor number 1, we have this thing here. So we have 500 coming in, 7 C1 going out. Okay, so in this case here, so let's do this. I'm looking at this reactor here. So let's do one by one. So this one here is coming in as positive 500. 500. This is going out minus 5. This is done minus 5 C1. This is coming in plus 2 C2 plus 3 C3 minus 7 C1 must equal to 0. Okay, must equal to 0. So we rearrange.
Doctor, still 5 C1.
I mean, so oh, this one. Yeah, this one. So 5 C1, yeah. So minus 5 C1. Okay, minus 5 C1 equal to 0. So this is just the equation. So this is the governing equation. It says that mass coming in must equal to mass coming out. Okay, so all mass coming out must equal to mass coming in such a way that the total, the net, is equal to 0, which is this equation. So let's rearrange this. Let's rearrange this. I'm going to rearrange in terms of C1 first. So minus C1, minus 5, minus 12, minus 5. So this is minus 17, right? Minus 17 C1 plus then C2. There's no more C2, just 2 C2. And then C3, only one C3, 3 C3, and then plus 500 equal to 0. Right, so this is the equation. And in your question paper, it is slightly different. It is in a different arrangement, but it should give you the same answer. So in my answer, then that's the answer. So I know that for reactor 1, it becomes minus 17 C1 plus 2 C2 plus 3 C3 plus 500 equal to 0. And we can do the same thing for reactor 2. Okay, reactor number 2. Okay, just do the same thing. I don't think I need to repeat this, but look at this. Okay, let's erase this. Okay, so just look at this, whatever coming in, whatever going out. So my system is always coming in as positive, okay, going out as negative. Okay, so that is my style. So in this case, for example, plus 2 C2 plus 200 minus 14 C2 minus 5 C2 plus 2 C3 and then minus, what is this? Oh, this is 5, yeah? This one is 5, yeah? This one is 5. This one is 5 C1, yeah? 5 C1, this is C2. Okay, be careful with the labeling, yeah? I think I screw up here. So this is 5 C1, which is this one here. And then minus 2C, that's minus 2 C2. minus 2, C2 must equal to 0. Okay, so same thing. So I don't think we need to go over that. So it's very straightforward. So this one is just 5C1 minus 21C2 plus 2C3 plus 200 equal to 0. And the same thing for reactor number 3. Do the same thing. This is 5C1 plus 5C2 minus 22C3 plus 30 equal to 0. Okay, very straightforward. Very straightforward. This is just this is setting up the governing equations. So the next one is, of course, trying to solve the governing equation. Trying to solve the governing equation. So I think part B is asking us about develop the mass balance equation for the other two reactors. Okay, we are done with that, and put it in this form. Put it in this form, in matrix form. In matrix form. So let's do that. So this is part B. This is part A. These two are part B. And then part C is just to put it in this format. A times B. Oh, sorry. A times X equal to B. A times X equal to B. So let's do that. So in this case, we have reactor 1, reactor 1, reactor 2, reactor 3. So what I'm going to do is I'm going to have a, how many unknowns are there here? How many unknowns there? In this question, how many unknowns?
3.
3 unknowns. So you expect the size of the matrix is?
3 by 3.
3 by 3, right? So 3 by 3. So I know the first column is going to be for my C1, yeah? C1, C2, and C3. So my reactor number 1 is minus 17 plus 2 plus 3. Okay, and then reactor number 2 is 5 minus 21 and plus 2 and 5, 5 and minus 22. So this is my A matrix, which it is called as coefficient matrix. And these are my unknowns, which is C1, C2, and C3. And then must equal to this value. Note that this should be minus 500 minus 200 minus 30. Okay? Because I put my known value here to the right hand side, yeah? To the right hand side. So this is the answer for part B, yeah? Very straightforward. Sorry, part C. Sorry, part B, yeah? Part B. Part B. Okay. Part C, it says that solve the equation simultaneously for the unknown. Okay, solve the equation simultaneously for the unknown, C1, C2, C2, a minimum of 4 decimal places using Gaussian elimination. Please show the detail of your calculation. Eh? So I know a 3 by 3 matrix is easily can be solved by using your calculator, right? So the whole idea here again is not to use your calculator, but you can use your calculator to check if you get the right answer. But I still need you to show me your steps, okay? Because the mark is at the steps, not the answer. Okay, so be sure that you show all the steps. Okay, be sure that you show all the steps. So now, so normally what people do, or what I do, is I put this in what we call augmented matrix form. Eh? Augmented matrix. Okay, I put it in augmented matrix form, which is just simply the E matrix okay, 5 minus 21, 2, 5, 5 minus 22, and I augment that A matrix, okay, that is why it's called augmented. Augment means just to add, add this one. So minus 500, minus 200, and minus 30. So then what you need to do is to solve this using your Gaussian elimination. Gaussian elimination. So what is the formula for Gauss elimination? What are the steps? What are the steps? So I know some of you, I didn't check your answer yet, but I know some of you just use elimination, not Gaussian elimination. There's difference. There are elimination, there are specifically what we call Gauss elimination. Okay, if you read your textbook, there's even naive Gauss elimination. Okay, so elimination and Gaussian elimination are two different things. So this question specifically asks for Gaussian elimination. Okay, so how do we do this? How do we do this? So let's say this is my row 1. So it happened that reactor is also R. So this is my row 1, my row 2, and my row 3. Okay, row 1, row 2, and row 3. So, and as you know, this is your A11, A12, A13, A21, A22, A23, and so on. So now what we want to do is the target of Gauss elimination is to have this 0. So this is the diagonal, and lower, what we call this is upper triangular matrix. So we want to develop, we want to process this matrix, augmented matrix, to become a upper triangular matrix. So the lower triangular is 0. So that is the idea. So what we want to do is to make this 0, and this 0. Okay, using Gaussian elimination. So the step is, how can we get rid of this? Okay, how can we get rid of this? So we need to get rid of this if we minus 5, right? We minus 5. So this becomes 0. And then this also become 0. So let's look at the steps here. So let me use this formulation. Let's say R2 prime. So there's a R2 and there are R2 prime. So there R2 prime means after first iteration. So 1 prime means 1 iteration. Row 2 after first iteration. So row 2 after first iteration is just so let's do this. Let me write this first. Okay, let me write the augmented matrix again. 17, 2, 3. Maybe we need more room here. Make it bigger here. So 3. Okay. Minus 500. So now this is still row 1, but now this is my new row after first iteration, R2 prime and R3 prime after first iteration. So what is the R2 value? R2 value. Oh, I should have put it somewhere else. Never mind. So let's do this. So R2 prime, okay, is equal. The formula is always R2, which is this row here, this row right here, minus A21, the first element of the second row, divided by the first element of the first row. Okay, times R1. Okay, so that's the basic formulation for Gauss elimination. So let's say, because we have 3 rows, 2 rows, 3 columns. So this J is the column. Column. Okay, so that's the formula. So in this case, our R21, which is just R2J, which is 5, this one, 5, minus A21. A21 is this, 5, over minus over A11, which is 5 over minus 17. 5 minus 17 times R1J, which is this one, minus 17, which is minus 17. So this is equal to, okay, what is this value equal to? So 5 minus 5, right? This one cancel out. 5 minus 5 become 0. So note that we have eliminated this one here, 0. Okay. So what is R prime to 2? So R prime to 2 is just minus 21 minus 5 over minus 17 times 2 times 2 equal to, hopefully, what is the answer here? Minus 20.4. Minus 20.4117.6, yeah? So this is minus 20.4117.6. And if you do for R3, again, you get the same thing, which is R prime to 3 equal to, in this case, it is 2 minus 5 over 17 times 3. 3, and this should equal to 2.88235. 2.8835 to 88235. And then the last one for, in this case, this value here. So this is our B, B2, B prime 2 is just this value, which is minus 200, minus 200 minus 5 over 17 times minus 500. And this should be equal to minus 347.05882. Okay, so this is the solution here. So minus 347.05882. And of course, you can do the same thing for R3. Okay, for R3. So I do not want to bore you with the calculation, but can you see that this process is repeated over and over? The first thing that you need to do is to find what is your A21 over A11, which is this over this. Okay, and then everything is just this minus the coefficient times this. This minus coefficient times this, and you can find the R2 prime. So now the same thing for R3 prime. Yeah? So the same thing for R prime 3 J, it is just R3, sorry, not R3 prime, just R3 minus, now the coefficient is A31 over A11 times R1. Okay, R1. So this is of course J and J, and of course R31 equal to R31 minus in this case R which is 5 over 17. The same coefficient, 5 over 17. So now this is minus 5 over 17 times R1 1. Okay, R prime 32 equal to R32 minus 5 over 17 R1 2. And R33 prime equal to R33 minus the coefficient, which is minus 17 times R1, R1, 3. And then B3 is just R, oh, sorry, not R. Wait, what's the formula? B3 prime, sorry, B3 prime is equal to B3 minus 5 over 17 B1. So this is the formula. This is the formula. So you can just do this. Okay, so this is very easy to program. This is very easy to program. So what changes is only the column index, column index 1, 2, 3. This is the row index. 3, 3, 3 is the row index. So this is why Gaussian elimination is very good for programming. It's straightforward. It's straightforward. So let me see what is my solution here. So to check for my solution, hold on. I think my PC is having problem. It's using up a lot of memories here. Okay, so let's do this. Okay. Okay, so now I have my solution here. So R31 is basically, of course, this will be 0, 0, and 5.588. So let's just write it here. 0. Okay, then this is 5.588 to 4 minus 21.1176, and then this is minus 177.059. So this is what I want to see. This is what I want to see. All this. This is the one that giving you marks in your test. Okay, not just the solution. So this is after first iteration. After first iteration. Now what we need to do is second iteration. Second round. Now our second round, this is still R1. This is now R2 prime. So sorry, this one become R2 prime. Now this one should be R double prime to R double prime 3. So what is our R2 prime now? What is our R2 double prime? So R2 double prime, just like before, this is just R2 prime minus coefficient minus R2, sorry, not R2, R1. Sorry, R2 prime. So what are we doing here? Now we know that this is already 0, right? So what we need to do is to make this 0. Oh, sorry, this is not R2, but R3. Sorry. This is still R prime, but this one is now because R3 prime. So now R3 double prime is just R3 prime minus coefficient, okay, with R2 prime here, R2 prime. Okay, so now what we need to do is to eliminate this, right? So to eliminate this, we need to compare these two rows. Only these two rows, yeah? So which is A, 3, 2, and A, 2, 2. Okay, so that is the one that we use. Okay, so let's do this. Let's do this. So what is A32? Okay, now this is after the first iteration over A prime to 2, which in this case R3 prime is minus 5.58. Okay, and so on, minus 5.58 over 20.411 times minus 20 over 2411, and this becomes 0. So what you have here now, let me rewrite this after the, and of course you can do this. This is for R32, 32, and 32, 2, 2, and then R33 double prime equal to R33 prime minus A32 prime, A22 prime times R3 3 prime. Okay, and this equal to this value. And of course, now we have B prime 3, which is now B prime 3 minus A prime 2, A prime 3, 2, and then B prime 3. So this is the value that I get. So this is minus 20.3285, and this one become minus 272.075. So if you take a look at this, so it will become, this is the same, 17 minus 17 to 3 minus 500. And this become 20 minus 20.411 and so on. And then this become 2.882 and so on. And this is minus 347.059. This is from the original equation. This is after the second iteration, which is this one here. And finally, now this is still R prime, right? Which is after the first iteration. And this one is now R double prime. So this becomes 0, 0. And minus 20.32 and so on. Minus 272 and 075. So now you can see that this is already the process of elimination. We have eliminated, okay, all the unknowns, because if you look at this equation is basically just our C3 minus 2032 and so on, C3 equal to minus 272.075. So this is the process of elimination. Now this is the process of backward substitution. Backward substitution. Substitution. So we know from this matrix is that 22.20 minus 20.3285 C3 equal this times X3 equal to minus 272 minus 272.075, and we solve for C3, then C3 is positive of lebih kurang 13, about 10, 13.3839. Take note, your answer might be slightly different than mine because this solution is using my calculator, where my calculator can straight away solve it. I think if you do your Gaussian elimination manually, there's some decimal places error here because of the round off error and so on. So of course, now how about C2? From here, we know that C2, 20.411 C2 plus 2.88 C3 equal to this value here. So we can rewrite that as minus 20.4118 C2 plus 2.88235 C3 must equal to minus 347.059. And since C3 is already known, then what we can do is C2 equal to minus 347.059 minus 288.235 times 13.3839, because this is C3 over minus 20.4118. Then C2 is equal to 18.8928. Okay, this is C2. And of course, you can do the same thing for the third equation. You get C1 equal to 33.9963. Okay, so these are my solution. So how do I know my answers are correct? Okay, stepwise. I know stepwise it is correct because this is just repetition. But how do I know my numbers, my value of C1, C2, and C3 are correct? How do I know?
I substituted in the first equation to check.
Okay, so you can substitute the values that you have, C1, C2, C3, in any of the three equations, in any of the three original equations. Okay, you can just try the first equation right here, and it should give you 0. Okay, in this case 0, because this is already 500. So any one of these three, anyone. If you want, you can, if you test with one equation, then you get all the values are correct, then this should be confirmed. Then of course, if one is okay, then the three are okay. The other two are okay. So this is how. This is how. I remember one student wrote by using calculator. How do you check? You check by using calculator. Of course, you can check with your calculator, but your calculator just gives you the values, right? So in this case, the correct way of checking is to resubstitute the values of C1, C2, and C3 into the original equation and see what are the results. Okay, so this is question number 1. This is question number 1, which is straightforward. Straightforward. What I'm worried about is that the students might not show this, might not show the steps, which is because most of the marks will go here. It's not going to be here. Okay, the marks will not be at this point, or this point. Okay, it's the steps that counts most. Okay, the understanding of the steps. Okay, so the next one is, of course, the Gauss-Jordan elimination. So what's the difference between Gauss-Jordan and Gauss elimination? What's the difference? Okay, remember that what we did just now was to make the coefficient matrix as only upper triangular. Only upper triangular. So this is Gauss elimination. Gauss elimination. Gauss elimination. How about Gauss-Jordan elimination? So what's the difference between Gauss-Jordan and Gauss elimination? So what's the idea here? What's the idea behind Gauss-Jordan and Gauss-Jordan Gauss elimination? So we know that this is what we want for Gauss-Jordan, Gauss elimination. For Gauss-Jordan, what we need to do is we have our diagonal as 1, 1, 1, and this is 0 and 0. So in this case, if we do this, we have, let's say, C1, C2, and C3. If you do this correctly, you get 0 on the upper triangular, and the upper triangular, and at the lower triangular, and 1, 1, 1 at the diagonal. So basically, if you do the iteration until you achieve this, then you get you should get the answer straight away. There's no substitution. There's no backward substitution. Only forward elimination. Only forward elimination. So now it becomes it will become this 39.9963 and 18.8928, and this one becomes 13.3839. Okay, I can show you my Excel sheet for Gauss-Jordan and Gauss elimination. So both of them are the same. The answer should be the same. But what do you think about the steps? What about you about the steps? Do you think Gauss-Jordan is easier than Gauss elimination?
No.
So why is it not as easy as Gauss elimination?
More steps.
More steps, okay, more steps, more, and it's time consuming. So let me show you my Excel sheet here. You can program this. Okay, so this is my Excel sheet here. This is my Excel sheet. So let's zoom a little bit so you can see. Okay, so this is the original matrix. Okay, this is the original matrix. And then this is after first iteration, that's the second iteration, then we can get the solution. So this is Gauss-Jordan. Gauss-Jordan. I do not like to do this manually, so that is why I'm doing this using Excel. So it should give you the same answer. And of course, there are Gauss-Seidel and Jacobi, which is for the iterative method. So note that some people say that iterative method is easier. Of course, it is easier because it is just calculation and calculation. But there's one problem here. Let's say I put this minus. Okay, before that, you can see that the answer is converging to the value that we want. So you can see that this is the same as the answer that we want as our Gauss-Jordan and Gauss elimination. But if I change this to -2, what is the solution here? What's the solution here? No solution. It's not converging. The same thing with Gauss-Seidel. Okay, Gauss-Seidel, you can see that this is already converging. This is already converging to a fixed value, which is this is our value that we want. But when I switch this to -2, then this is not converging. This is diverging. So that's the warning about when you use iterative methods. Be very careful because in this case, it is not stable because of my diagonal. This is okay. My diagonal for the first row. Okay, my diagonal for this one. This is 17, which is the largest value in this coefficient matrix. For my second row is also the same. This is the biggest out of this coefficient matrix row. But this one, this is 5, this is 5, this is -2. If I take this absolute value, this is the smallest one. So this is why one of the reasons, even though iterative method is easier, but it is normally unstable. Okay, so we have running out of time. So let's talk about the second question. Okay, because we are running out of time, I think you have another class after this, right? So let's go to the second question. The second question, I'll go quickly. The second question is this one here. Okay, so I think this is again the same one. So what's coming in must equal to what's coming out at junction 1, junction 2, junction 3, and junction 4. So what I have for my equation for the second question is this one. So what I get here is 1 0 0 1 1 1 0 0 0 1 1 0 0 0 1 1. Okay. And then we have, of course, F1, F2, F3, and F4. This is 300, 500, 1000, and 800. Okay, so if you do Gauss elimination, okay, you get, if you do it properly, what you get at the final step is that 1, 0, 0, 1, 1, 0 minus 1, 1, 1, and then 0. And of course, this is 0. This is the lower triangular. This is 300, 200, 800, and then 0. Okay, I think I mentioned this in your assignment number 1. I don't remember assignment. Oh, no, in my other class. Note that this is the last one, right? We say basically this is 0, F4 equal to 0. And F4 is 0 over 0. What is 0 over 0?
Undefined.
Normally, if you have any value on top, divide by 0, then it's undefined. But if you have 0 on top, then you know it's going to be 0. Okay, I don't know, I'm not a mathematician, but we can simply say that, in this case, let's say that this is undefined. Eh? Undefined. So what's the issue here then? What's the issue here? When you get this kind of equation, what can we say about this? So this question number 2 is not about Gaussian elimination, but it's more about understanding. Eh? It's more about that. As you can see here, when we do the Gaussian elimination, we have only 1, 2, 3 equations, because this is basically not an equation, because all of them are 0, 0, and 0. Eh? So basically what we have here is 4 unknowns with 3 equations. Am I correct? So this is the one that I want you to learn actually. So in mathematics, if you have 4 equations, if you have 4 unknowns, you have to have 4 equations. If you have 4 unknowns and you have only 3 equations, can you solve? Can you solve for the unknowns? Okay, this is what I'm trying to tell you for the second assignment, the second question for the question. So in this case, we do not know what is. We do not know one of the unknown, because there's not enough information. We have 4 unknowns, but we have only 3 information that can be used to solve this equation. So unless another one is given to you, then you can solve. For example, if I give you F1 equal to 200, can you solve? Yes. Now it's 3 equations with 3 unknowns. Before this, it was F1, F2, F3, and F4. But you have only 3 equations, so you cannot solve. You cannot solve the equations. You cannot solve for the unknowns. Now I've given you F1 equal to 200. Can you solve for F2, F3, and F4? Can you? Anyone?
Yes.
Yes. So this is the important thing that I want to say to you. Yeah. So if you don't do this on your own, then you might not understand this. Okay. So I think I need to stop now, because I don't want to hold you for your next class. Yeah? So thank you very much for staying. I have about 8 minutes overtime. I'm 8 minutes overtime. So I think until the next session, next live session. So I'll see you again. Sunday, right? Sunday, right? Okay. Thank you, everyone, and have a nice weekend. Don't forget, I already put the assignment 4, which is the eigenvalue, eigenvector problem, which will be covered in our test. Okay. So everyone, thank you.
Doctor, if you have the analysis of the Gauss-Jordan elimination, can you share it with us?
No, you can watch my video.
No, because in the video is in Excel, so I didn't know how to do it. So
what's the problem?
I mean in the steps.
The step is given in the lecture video, and of course in this video, in this session.
Okay.
Okay. All right. So thank you, everyone. See you Guys, later, and selamat berbuka puasa and nice weekend. Don't forget assignment number 4. Thank you very much.